Scientists like Ray Baughmann at the University of Texas are exploring the remarkable properties of a brand new material, the carbon nanotube.
Dave, this is one type of carbon nanotube.
This is what it's all about right here.
This is what it's all about.
You know, I had a hunch it'd be like this. I just thought they'd be smaller. I'm right. They're about 1 billion times smaller. Nanotubes are made of carbon atoms arranged in a rolled-up, chicken wire-like structure. Besides nanotubes, there are other forms of pure carbon, like diamond, and graphite, the stuff of pencil lead. Nanotubes get their strength from the extremely strong bonds between carbon atoms.
These carbon nanotubes can have spectacular mechanical properties, spectacular strength, and very high toughness.
And you make them here in this very lab?
Yes, we do.
Ah, so this is where it all happens.
This is where the process begins.
And guess what? It's not even that difficult. Here's all you need. 1. A smooth surface with a thin layer of catalyst, a chemical that helps jumpstart the tubes. 2. A special mix of gases full of carbon atoms. And 3. This furnace, which, by the way, is really, really hot. How much heat is it in there?
Right now it's around 800 Celsius.
That's about 1,500 degrees Fahrenheit. Wow, I could nuke a pizza in like 5 seconds in there.
Yeah. You can open more.
Oh man, that is blasting heat. Oh, I see the little black wafer in there, that's it?
Yep.
That's nanotubes?
Yeah, exactly.
Wow, that is very cool, baking away in there. Wow, it's like a nuclear tanning bed. After just a few hours, the wafer is covered with a thick black fuzz. So it looks just like a piece of black velvet. So if I were to really look in close to that, what would I see? What's it really look like under the microscope?
Well, we call this array of carbon nanotubes a nanotube forest.
The name is apt. Each nanotube looks like a tall, thin bamboo tree, hollow inside. So thin that if you could scale one up until it was 1 inch wide at the base, the top of it would reach 2 miles into the sky. Now picture nanotubes by the billions, all standing shoulder to shoulder, and you have one of Ray's nanotube forests.
There are, in fact, about 200 billion of the carbon nanotubes in that area.
Hold on 1 second, I'm going to count them. Actually, I shouldn't be touching these. Scientists don't yet know if they're toxic. Even so, there's already a rapidly growing market for nanotube particles, as strength additives for tennis rackets, bicycle frames, even high-end car bumpers. Many products already incorporate carbon fibers, which are part carbon, part plastic. But nanotubes have greater tensile strength and toughness. Ray has set his sights on making super strong materials that are 100% pure nanotube, made from his nanotube forests.
These aren't just ordinary carbon nanotube forests. They are nanotube forests that have a very special type of connectivity between nanotubes. When we pull out one nanotube, that nanotube pulls out its neighbors, who pulls out other neighbors to self-assemble a yarn or a sheet.
Expert nano yarn spinner Kai Lewis gives me a hands-on lesson.
Would you like to try?
This I recognize. This is that. First, we start with a forest on a wafer.
So you can just grab on to this little orange tab.
Okay.
Now don't make it too high of an angle and make sure it doesn't touch the edge, and just pull out.
Fast or slow?
Whichever you feel comfortable with.
Oh, dude. As I pull on this little tab, nanotubes are coming off the wafer, hooking other nanotubes and pulling them off the slide.
Try faster.
I'm so good at this.
And at too high of an angle, it will, as this is now, it'll start to break off from the forest.
It's like coming out forever. I'll see you at the Texas County line. It's still going. It's still going.
There, it broke. And what's even neater, I can show you right here. I can even do a little twist and
you're making
make that into a yarn right here.
Insta yarn.
Look at that.
Wow.
It's about 1/100th of a human hair.
Oh my gosh, it is like steel. I'm pulling really hard. You probably can't even see that. In fact,
And it
look
will
at this.
stay.
It's so fine, you can't even see. Oh, that helps.
Keep twisting. Keep twisting.
Keep twisting. Okay. It's amazing.
It's stronger than steel.
Stronger than steel? So why then don't you take a bunch of these, twist them together, and make this super cable that'll be like bridge suspension cables and aircraft carrier cables?
Can you imagine spinning a bunch of these all day long to make into a rope that's a foot in
All right,
diameter?
so go the other way. Make the aircraft carriers really, really small.